Welcome back. So our next one that we're going to look at is the limit as x approaches 5 from the left of square root x minus 5. And with this, I'm going to look at this one too, and we'll do it at the same time. X approaches 5 from the right of the square root of x minus 5. Now, I don't want to do this algebraically. Well, I can. I'm going to do it kind of algebraically. If I'm on the left-hand side of 5, there's so many different ways to do this, and I'm going to employ different tools and strategies, and you need to start doing the same thing. If I'm on the left-hand side of 5, I'm choosing values of x that are less than 5. Do you agree? So you're going to choose values like 4.9, 4.99, 4.999. Do we agree? And if I take these values and I plug them in for x, what's going to happen to the argument underneath the square root sign? What's going to happen? Is it going to be positive or negative? So if I take values that are less than 5, 4.9, and I subtract 5 from it, what am I going to get out of this? I'm going to get a negative, aren't I? These are going to give me negatives. So I'm going to get a negative under the square root sign. I'm going to get the square root of a negative number. Are those real numbers? No, those are complex numbers. Those are imaginary. They're not real numbers. So if I'm going to get not real numbers, does the limit exist? No. And that's what, so did you see how I did that question? Not a lot of computation, a lot of just sort of thinking it through. That does not exist at all. It doesn't go to infinity, doesn't go to negative infinity. It does not exist. It's not a real number. L is not a real number. Now, using the exact same logic over here, if I look at values of x that are greater than 5, they're going to be things like 5.1, 5.01, 5.001. And if I take them and plug them into there, I'm going to be left with positive numbers. Do you agree? So the argument is going to be positive. So that means I'm going to get an answer. That means the limit's going to exist. Now I got to figure out what it is. So think to yourself. If I do 5.1 subtract 5, I'm going to get 0.1. So you can do your little chart. You can do your little chart. So you're going to get x greater than 5. 5.1, you're going to have x minus 5, 0.1 square rooted, whatever that is. I'm not even going to bother figuring it out because I see a pattern here. This is going to be 0.01 square rooted. And this one's going to be 0.001 square rooted. Notice how I'm using my I'm not using my calculator. I'm not getting the decimal. I don't need to. I'm going to be a little bit smart up here. And I know that that number is getting smaller and smaller and smaller and smaller. Would you agree? So that's approaching 0. So I wouldn't bother working that out. I would then say, okay, so the limit as x approaches 5 from the right of this is 0. And so if the left-handed limit doesn't exist, but the right-handed limit does exist, the two-handed limit doesn't exist. And you know what's really cool about this? I could have done this completely different if I remembered my grade 11. Do you remember that function? Root x? Well, that function is moved 5 to the right. This is root x minus 5. So guess what? Everything to the left of 5 cannot be done because it's not defined in the real number system. You're getting complex numbers, so it's not defined. And moving from the left or moving from the right, you see that you're approaching 0. So here's a graphical representation of what I came up with algebraically. So oddly enough, the two match. Go figure. And I want you to be able to do both. It's very important. Okay, I'm going to stop the video there and we'll be back in a moment.